Welcome, everybody, to the Zion Experience. I'm Jim Shaw. I forget Jordan. Jordan Frank, the other co-host, is on.
I'm here.
You know, we really don't prepare for this.
You know, we're better off to come. That's about all you're going to get. Yeah, that's what I got.
I have ham and cheese loaf in the refrigerator for days like today.
With that, let's get back into it.
Let's get in our groove. Well, hello and welcome to another episode of the Zion Experience, or the TZE as we call it. And we're glad to have you out there with us today. I've got Drew Eubank sitting in for the normal co-host, Jordan Frank, and we've got an exciting returning guest. We always enjoy our time with Sriram. I'm not going to pronounce his last name. I'm going to let him do that. And we've got Sriram is the CEO of North America from Addverb, a good friend. Known Sriram going on about 4 years now. It's been about 4 years since I think I cold called you out of LinkedIn, or maybe messaged you out of LinkedIn. And now 4 years later, we've got a relationship. We've done several projects together, and just one of the all around good ones in the industry. And what we're going to bring to you today is we're going to talk about the digital twin technology. The name digital twin's really been out in the marketplace for quite some time now, but I'm excited to talk about how Addverb's using this technology. We have looked into using it. We haven't used it as much as probably you all have, Sriram, but I'm excited to learn more about it today. So without further ado, I'm gonna let you introduce yourself real quick, and then I'll kind of describe the episode, and we'll jump right in. We'll jump right into it. So.
Beautiful. No, thanks, Jimmy.
Yeah.
I appreciate you guys setting this up. Always love to get back into the saddle with you guys on this podcast. Lovely intro, by the way. I love the music. I love the banter, because I think that's what Zion is all about. But I mean, between that banter, there's a lot of solid insights and value addition. So I think you guys are doing a great job with this podcast. I'm a big fan. I keep listening to it whenever I can. But no, my name is Sriram Sridhar, just to pronounce that right. Jimmy does a good job. I think in the 4 years, the pronunciation impact has gone level by level. But now I run our operations here for Addverb. Been in this industry for close to 15 years now. I've done a variety of different things in this space. Started off as an engineer, doing design engineering with electronics and automation, then did programming, did a little bit of software implementation, then went into project management, and for the last several years focused on the most passionate thing for me as a person, just really to have conversations with our clients, our partners, to see how we could solve problems within the four walls of the warehouse, and offer my 2 cents on making it more efficient and scalable for the the tasks ahead. So that's me. I think, like I said, this is a relationship between Zion and Addverb that's lasted ever since probably Zion began in 2022, and around the same time when we established ourselves in this part of the world. And I think it's just gone stronger and stronger. So again, appreciate all the good stuff that you've done. In fact, my background is a testament to this partnership. And I intentionally put that together because this is one of the facilities that we have done together. We are bound by an NDA, so I can't say more. But I think the fact that with Zion's experience of system integration within our expertise in products and solutions when it comes to AMRs, AGV shuttles, I think this is a partnership that's lasted long. So excited to talk more about digital twin, because I think it's becoming more of a reality than an art. So happy to share my 2 cents on what it is and discuss with both of you today.
That's awesome. Well, thanks again for joining us. And I did notice the background. I like the background. It's a good looking picture. So if you're out there just listening to us, you can find this. We've got the video in a couple different spots, but YouTube is probably your easiest spot to find it. And you can see the video in the background that Sriram is talking about. So what are we going to talk about in this episode? That really, at the end of it, what we hope you all walk away with is ultimately what is a digital twin. I think there might be some misunderstandings of what is a true digital twin, and ultimately why they matter. How are digital twins helping solve some of the challenges that we're seeing day to day as integrators, as OEM providers, into what challenges are warehouse and what are people seeing and what are they trying to get a digital twin to help them see around the corner, as we call it. And then what's the role in automation and peak planning? Can they be used beyond just the normal challenges? And I think you're going to find out the answer to all this is yes. You know, it's been a buzzword in the industry. There's several companies that do this, that offer this, that have upped their game in terms of providing a true digital twin. And I think you're going to be interested. I know our audience is going to be educated coming out of this, and they're going to be interested in how they can apply this to maybe their operation or their partnership that they've got, and how can they use it going forward. So I'm going to jump right into the questions. Unless big guy Drew, you got anything you need to?
Yeah, I think one of the things too, like we talk about buzzwords. There's two buzzwords that are very close together. One's digital twin and one's operating twin. And I think that it's important to have a distinction between the two because they are slightly different. Kind of like simulation and emulation were confusing for so long. I think digital twin and operating twin are probably the same level of confusion. They're close enough cousins to confuse you, but not close enough to call them the same thing.
Gotcha. Cool. That's a newer term to me. So I'm interested to hear what an operating twin is in addition to a digital twin. I know what a digital twin is, but I'm interested to hear it. So let's just jump in. So maybe people are like me and they're unfamiliar with the concept of what an operating twin is, but let's focus on digital twin first and then just add to it the operational twin spin. But what is a digital twin and how do they differ like from maybe some tools that have been in the industry for a while? So Sriram, in your opinion, explain to the person that maybe isn't as familiar, or the operator that doesn't play with software every day or is not designing and engineering every day, what is a digital twin at its basis?
Yeah, I mean, I think I completely agree with Drew's point. I think this is one of those things which is an evolving definition as far as digital twin is concerned, because we are living in the day and age of obviously generic AI. So this is constantly changing. So take it with a pinch of salt. I think all of what at least what I'm going to share is probably our interpretation of digital twin, and that might be different for different people, different industries, different problem statements to solve. But the way I've done my research on it, and obviously we experience on a day-to-day basis. In fact, I was just sharing that I'm just coming off a digital twin discussion internally for a large customer that we are actually implementing. And even in those conversations, we were evolving the discussion around what is the definition of digital twin. So it's an evolving conversation. But the simplest way to kind of imagine this is an AutoCAD layout is also a digital twin. If you look at it at the simplest level, right? You put an AutoCAD drawing together, which is effectively a replica of the physical, matter that you kind of install in an actual environment. So the simplest form of a digital twin is actually an AutoCAD. Now, once you start giving some life to that AutoCAD, that's when you start moving into the levels of what a digital twin could be. But I think at the heart of it, the definition of digital twin is you're trying to create a digital replica of your physical model, just so that it helps you imagine, estimate, project what your physical model would do subject to a certain input and output variables. Because at the end of the day, these are machines, these are systems. And any machine, any system really works on the broad dynamics of there's an input, there's a process, and there's an output. And because these machines are so complex, the number of inputs and the number of outputs are all parallel tasks. And that's where the digital twin allows you to tweak these input variables and for you to check what those output variables may be. And the change of state, again, depends on what is the current data set that is existing. So at a broad level, the digital twin allows you to test what your physical model would do subject to various what if scenarios, and allow you to understand, if I change these variables, what eventually happens to the model. And therefore you can take better decisions in terms of whether you want to change those variables or not. That's one aspect of it. And I think digital twin has evolved from simulation to emulation to an emulation plus. And the real digital twin is, to what Drew said, is an operating twin as well. So you make another phygital model that's running parallel to the actual model, which is constantly taking the real-time data, so that you create a living organism of the physical organism that sticks, and then work your way to understand what the specifics may be. So that's it's quite a bit. So we'll try to decompose this as we go through, but effectively that's the interpretation that we have at Addverb.
Gotcha. Drew, you want to add anything to it?
No, I think Sriram put it very well. We've had simulations and emulations for a while, but a digital twin is a real live feed for an existing operation that if I go in and this is Drew simplicity, by the way, so I might be full of it, but if I go and make any systemic changes or make any physical changes, how does it impact, right? And you have organizations who literally can tell you the best travel paths for work being done using the digital twin and actually running, hey, you're going to be 1,000 less feet if you do this travel path on your pick path, which just takes it further, and it provides a visual output to a systemic input that's easier to understand, I think, because I think a lot of times one of the problems with simulations and emulations, they're at the front end, right? You do that at the front end before you build. It's not built with it, so it's hard to see what those changes do, but it allows you to actually have a better educated guess at what's going to occur if I change this workflow or I change this pick path, and just gives you more confidence and ability to, your outcomes will be successful, removing that risk.
Gotcha. So asking from just a place of not knowing, Sriram, like what software ultimately is a digital twin, right? What software components are coming into play with that? Is that a standalone proprietary type software? Is it embedded through CAD, or how does one go about getting a digital twin?
It's a culmination of many things. Effectively, like I said, the root of all of this is a simulation software. So, I mean, if you use any typical simulation software, and we at Addverb, we use a backend of Siemens, and it's called Technomatics, which allows us to build digital twins and emulation models of not only the entire system, but even our physical products. So effectively, you're talking to a company which has already built an emulator, and that emulator can have plugins to talk to different real-time softwares. So it could be a real-time WMS, a real-time WES, WCS, and a real-time PLC code. So you're pulling all of that together to the digital model, which is essentially a 3D render and a sort of a small monitor version of the physical, 200,000 square feet physical model. And so it's really a culmination of different softwares that allows you to create a digital twin, and not just one. The base platform, like I said, we use Technomatics with Siemens. There's a few others that are out there in the market that can be used. NVIDIA, which is obviously big with AI, has also built their own tool around it. So there are a lot of options to do it, but again, it really depends on what your objective is from the digital twin. If your objective is, hey, I want a replica of my $100 million investment, I don't want to spend the $100 million. I would spend, whatever, $100,000 instead on the digital twin model to see what this $100 million investment does for me. That's one version of a digital twin. The other version of digital twin is, now I've spent the $100 million, the system's running, but I want to make some changes to the system. So I would take the data set from my existing $100 million investment to the digital twin, make some tweaks around it, see how it performs, and then decide whether I want to make those changes or not. So it depends on what your objective is as far as the twin is concerned, and the results would be different accordingly. So that's really what the gist is.
Gotcha. That's interesting. I think both of you all have done a good job of explaining it. I'm more of I was really dialed into what a simulation was and an emulation was. And I agree. It's more of a static viewpoint at the beginning of the process. Maybe an emulation you can take a little further. You could probably, that's what's evolved into today's version of a digital twin. You could truly, layer on your PLC. You can see how the messages are going to work, how it's going to work with still simulated data and input. But I could see some real advantage of now you're actually running in the operation, and you see this change and you can understand the impacts of it. So if we pivoted into that and leaned into that a little bit, what are I guess, Sriram, starting with you and then Drew jump in as well, is like, what are you seeing? What challenges is this technology best suited to help in maybe a warehouse environment? Like, what are you trying to break? I don't want to put it that way, but it's really is. Like, what challenges are you trying to see? And you mentioned peak, you mentioned after I'm operational. Maybe it's before I make the investment. I'm not sure which angle you want to take on it, but sell me on it, Sriram. I need a digital twin, and you're trying to sell me in the audience on it, right? What challenges would it tell me I've got, or is it just a big fancy $100,000 piece of software?
No, like I said, I think throughout this conversation today, I'll try to unpack this because it is a little overwhelming for a lot of people out there. So I'm just going to try my best to, really, for lack of a better word, dumb it down for all of us. But the word digital twin was actually coined by NASA. And you won't believe it, this actually is reality from the 1960s. So it's been existing since then. The first real use case that we researched was in one of the Apollo 13 missions, which had so whatever, the mission was up in the space and there was a challenge. Something conked off. I won't get into the specifics of it, but something happened. And the people on the ground had to take some decisions and convey those decisions back to the people out in the space. So what they did was they did exactly that, which is they created a virtual model of the state of that rocket or whatever that mission is here, and then they made some adjustments to the virtual model to see if they made these adjustments, and those adjustments could be, get the data from a sensor, actuators and so on, what would be the impact on the ground. So essentially it's a great way to pilot a change to an existing complicated system to assess if that change will have a positive impact or a negative impact. If it's a negative impact, it allows you to do trial and errors, and the risk is much lesser, because if you're trying to do trial and error on a physical system, the risk is too much. System might stop, you might not be able to get orders out of your warehouse. The risk is just too much. So that's what it's solving for at its root. So I'll give you another real world example that we are currently tackling. So we work with 3PLs, as you know, and 3PLs today bring a customer on board into an automated system. Now this, for example, most 3PLs are now moving towards what called a multi-client fulfillment, which is same physical facility, but they start fulfilling for multiple customers from the same automated system. Now, as they have run a single customer through our automated system, it's running well, great. Now they want to bring in a new customer's inventory into the new system. They wanted to see how the system adapts to the second client's inventory. B, they want to see, is there an impact of my first client's inventory and picking and order to dispatch times by introducing my second client's inventory. Now, instead of actually experimenting with the second client in a physical environment, you actually put it through the digital twin, see how it operates, do all the tests, do all the user acceptance tests through that, check it off. And if it gives you a positive result, that's when you go in and bring the physical inventory of the second customer in. So these are the kind of problems it solves. Ultimately, it's going from hope it works to yes, it will work approach. And that's really the crux of what it effectively solves for. So the time, the risk, and the cost that you will potentially lose are all protected with this digital twin model. I don't know, does that make sense? I think
it makes perfect sense. I think just to simplify it, again, using Drew lingo, it's another tool to de-risk what you're doing, right? It make no mistake, it's still only as good as the data in, data out. So if you put in garbage data, what are you going to get out of it, right? But it gives you a place based on that alignment and that assumption that, hey, if we do X, Y, Z, this is going to be successful. There's organizations out there that have been built in our space that's all they do is the digital operating twin model. That's their entire basis. And they're looking at it from a labor play perspective. Like, how do you take labor management to the next level by making sure that people are following optimal pick paths? It's a little bit reactionary because you say, hey guys, here's what you did today. Had you done this, you'd have saved 2 bodies today, right? It's just another great tool for the toolkit. And the good news is the better you get at it, the more we have it, the costs will come down and make it more palatable for folks. But it's definitely better than what you used to have from the simulation tools, right? And having to go in and emulating PLCs and attaching speeds and feeds and checking little boxes and things of that nature. It's definitely a step up from there to makes it actually more accessible, I think, than simulation used to be as well.
Gotcha. Well, I think it was interesting. I didn't know it was from the 60s, and it came out of NASA. And there's so many great technologies that have come out of either space exploration or just war in general. I mean, some of your most advanced technologies and systems come out of that. So it sounds to me like, if I recap what both you are saying, really it's a tool, an additional tool in your tool belt to reduce risk, maybe to increase or improve throughput, which what operations not looking to do that. Maybe even delay capital spending. So if you don't have to spend it today, why spend it? So if this can get you, this gives you a real world vision or view of like, okay, yeah, if you hold off, you've got this much more ability, you got this much more efficiency you can gain, you got this much more utilization. And you can just test future scenarios. Like, why the old way, like we've all kind of grown up in the warehouse of like, let's go try it. And then after it doesn't work or does work, then we know it worked or we know it didn't work. Instead, it's really being more proactive on the front end of what you all live with. Like, it's to de-risk.
What excites me is you're taking the sandbox method of software and now putting that software change into a physical environment. So you're not just saying, one, it's always a twin. It's always a copy of what exists, right? So you don't go back to, oh, it's my sandbox, my production, and if I do X, Y, Z, right? So it's always updated. So you have less risk of having functionality exist that doesn't exist in the sandbox, all that type of stuff. But it allows you to really get that visual output instead of just, oh, let's go, we regression tested everything. We thought we caught all of it, but damn it, we missed it because it's not a real twin, right? And then you go out the floor and it doesn't work and you stop. That's the exciting part for me, right? Is all that extra rework you have to do because it is complex and it is hard to catch all those details. And it is hard to have a truly mirrored sandbox to production environment in a cost-effective way. So to me, that's where there's a lot of bang for the buck, as well as how that software impacts your decision matrices inside of the system.
Yeah, and I think at the end of the day, any warehouse automation project, I think the reality is, unlike a factory or a machine, a warehouse automation project undergoes changes every day, because no single day, like yesterday is different from today and today is different from tomorrow, because that's the nature of warehouse. So the number of variables that you deal with is just too much for a human mind to understand. And I think somewhere digital twin is trying to simplify that. It doesn't oversimplify it to the level that it's a yes or no decision, but it does simplify it to the level that you can take lesser decisions in a faster amount of time, which again helps you de-risk anything that you're taking as far as the decision itself is concerned. So yeah, that's really what the gist is.
I mean, if you're sitting and you're a CFO or you're a large company or you're betting, you're betting the future of an organization or what you're leaning into, and you've got the ability for a relatively small expense to help you predict the future and make decisions, or at least de-risk from a facilities, from an automation, from software, from labor, all of the above. Why? I mean, for the right, it makes all the sense in the world. It's why digital twin has a place in our world. I don't know that everyone's leaning into it because it does have some heavy impacts. It has to have some interpretation. You have to, like anything else, have subject matter experts that can guide you through what it is, because it's not, here's your output, here's what you should do next, and I think we're going to see, we're at a pivotal moment or an inflection point, I think, in our industry and just in the world in general with AI. Is AI is only going to be as good as you're able to apply AI or ask AI to do what you are trying to get AI to do. I'm not saying that real well, but there's still that human piece. There's still that human element. There's still that human expertise that has to spark, here's how you use it. Here's what you do with it. So it's fascinating to me. The technology's been there for a long time. We've seen it. I couldn't tell you how many times, Drew, you both have probably felt this, as we had I've had the conversation with a customer. They thought they wanted a simulation. They thought they wanted an emulation. And I'm like, it's only going to be as good as the inputs that you put into it. So I can get it perfect, but if we're still wrong on the assumption, or we don't have data that's driving us to the correct order profiles or the correct volumes or the correct inventory or order spike that's going to happen in a day because you do, some kind of blast sale or you do some kind of flash sale is probably a better way to say it. It's only as good as your inputs and then you being able to do something with it. It's not an easy button. And there's a lot of work that goes into it. So I think there's a lot of components that play into it, but maybe let's have some fun with the last question. I think I've got one more I want to ask, and just some fun with it is, what are some of the biggest surprises you think companies can expect or have uncovered, maybe can expect to or have uncovered by when they build out a digital twin and when they're using one of these? What are some of the things that what are some of the big surprises you think that companies are seeing?
I think, what I've seen is you might be thinking that, automating a process is the right thing to do. But a lot of times, a lot of these tools allow to also tell you that, you don't need to automate because it doesn't deserve it, or it's too simplistic to automate it. So while it solves the problem of, again, making the right decision, but it also gives you insights that you never imagined. Because as I said, we cannot assess all variables in isolation, because all of these variables come and talk to each other and it just convolutes the whole thing. So I think that's one. Like I've been in conversations where we have done some, calculations on an Excel sheet, but then once you start putting into these tools, it gives you totally different results that you never expected, right? And it just allows you to make the right decision at the end of the day. Now, that's not just one thing, right? And it's also a iterative exercise, and that's where digital twins also help significantly, because what might work today might work tomorrow, because the impact of today will change the impact on tomorrow, because this is something that will run for a few weeks, for a few days. And so the first few weeks you might say, hey, you know what, it doesn't matter, let's just go and not buy these additional 4 robots to do this throughput. But within 2 weeks the results will change, and the decision making will be, you know what, maybe I don't need 4 robots, maybe I need 2 robots, but my assessment of not needing any more additional robots was wrong day 0 or day 1, because it takes time for these models to build out and give its true results. And that's the assessment that has come to a surprise to many of us, because data and math do their own magic in the background, and you can't see it, and I think it takes time for you to see and assess it.
I like how it's a tool that's more advanced, and to Sriram's point, crunch data all day long. You can make all the assumptions, but if I drop 6 months of post data into a system, into a digital twin, and watch it operate, it's inherently going to show you the bottlenecks you couldn't find just in the data. One of my redneck sayings is, data never lies, but never tells a story. Well, now it tells a better story because I'm using the tools that I have at my disposal to help tell that story. I think the biggest thing with it right now is it's still cost prohibitive unless the job's big. I mean, it's not a small undertaking. But if I'm going to invest 20, 30, 40 plus $1 million, it's a fail safe, right? Because you one miss on that and all of a sudden I'm up another 10, 20% to a project. That's much worse than the couple $100,000 it takes to put the digital twin together and then maybe the little service fee to have it continue on. I think people are starting to understand that it's important to take care of your entire system and not just the software component portion of it, to make sure you understand the impacts of decisions and the impacts that things are happening, because that profile, automation's flexible to an extent, but that profile still matters, right? And so just having those tools available to say, hey, if I add in this business with this type of profile, is it going to break me? It's a tremendous win. Doesn't mean it's always going to be right. It's always going to be right, but then you've got a much better chance of being right by having that assist in that tool.
Yeah, and I think you both mentioned something that I would think the digital twin's going to just call out is like, how many times have you all gotten into an operation and we're at capacity, but we shouldn't be. We should have excess capacity, but yet maybe a better way to say it is we're having throughput constraints, right? We should have all this capacity. And I think it comes down to the inherent nature of how we design these systems as humans most of the time and what we can process. And we're only as good as the data, right? To your point, Drew, it doesn't tell the story, but the a bottleneck is ultimately what's driving performance in a system. And a digital twin allows you to find those bottlenecks. And a lot of times we're designing on averages, and that's not the world, right? It's just not. So I think maybe back to the question, one of the surprises, I think operators would be pleasantly surprised at the right size operation, the right investment of, you've got this massive system that you're putting in. It's automation. The most expensive thing in the system is going to be a robot or some form of the automation sitting idle, not working, because you're paying for capacity that you're not using. And it's like, where are the true bottlenecks? I think it has the opportunity to expose the real bottlenecks. And that it may be software, Drew. It may be the software's not keeping up, or it may be your business model's throwing in spikes that the system just wasn't built to handle. Or it might be humans. There might be a human interaction somewhere in the system that is really creating a bottleneck that you can't overcome as the automation's built downstream from a process. So
I think we just finished an advisor engagement with a large fashion retailer, right? And they're having significant challenges with keeping an automated system fed with the right amount of inventory because they're fashion brand. They turn a lot. It'd be great to have a tool that could actually simulate or emulate real time. Guys, fill the system up. If you hit 90% of it, you've won. But if I've only got 20% available in the system, I'm never going to get anything out of the system. Like how to balance that and show people visually. It's no different that we do 3D CADs for customers who are in the C-suite or those people who aren't close to the process, to give them a visual of what something's going to look like. It's easy for us every day to see and go, oh, I can picture that mess sitting there 14 feet off the ground. Like, that's not hard. It gives that ability to help show that data in a different fashion that's easier to buy in and understand. Again, the biggest thing is right now it's still cost prohibitive. And I got linked to multiple systems, multiple data sets. I got a lot of front end lift, but that'll get better. That'll get better. It's one of those AI tools. It's for our industry is a big boon once it's landed and it's costed right. That can actually have an impact. It still takes a human design systems because it's much of an art as a science, right? But that little piece, that little back end piece will just give that confidence, and maybe customers will pull triggers quicker. Maybe we make better informed decisions on how to reduce cost. And hey, by the way, guys, this is your parameters that you have to fall into. Let me show you what happens if it breaks really quickly, instead of spending 3 weeks trying to get data right in a simulator to make sure that it comes out the right way.
Yeah, and I think also the real value of digital twin is for an existing system, not so much for a system that you're planning to install. So digital twin works, and most automation systems, especially in the warehouse, just because it's such a complex problem. I think out of 10 automated warehouses today, I won't be surprised if 7 automated warehouses are not hitting the targets that they need to be hitting, because it's very hard to there are so many variables. There's a labor variable, the order profile, the way you waive orders, very simple things like that. Again, if someone goes and try to assess what the problem is, they will again look at static data to make some decisions to try to enhance the output of the system. But the digital twin will give you much more filtered out data that will help you make the right decisions to enhance that throughput from 80% to 95%, right? And the way we've architectured it is there's a 3D, 2D layout. There's animation, which is a visualization. There is emulation, which is taking the real software and putting into the model. And digital twin is a culmination of all three. Visualization, emulation, and real world data of an existing system, and then a living organism that's sitting parallel to the actual physical system, where you can test, probe, do analysis to see how the system behaves. Or if this system, the physical system, is giving you data that's a little odd and funny, you can pump it back to the digital twin and run different analysis to figure out how the physical system will change to changing variables on your side. So it's a convoluted system, and that's why it makes it a little bit more complex. So I think if you're looking to build or work with someone on this, just understanding that roadmap of where it actually adds value is very critical.
Yeah, I think you put it well. And I said I was going to have the last question, but I am going to have one more question, Sriram. Is like, What happens when true AI and the digital twin converge? What happens in that world? Do things get even more interesting in terms of you take the human element of having to continuously optimize? You maybe take the predictability elements of what AI has. Are you seeing any? Are you all working on anything along those lines? I know you all are a very forward-thinking company and technology-wise, and does it get even more interesting when that pairing happens?
It does, and that's why I put a disclaimer at the very beginning, right? It's an evolving definition for digital twin. Like, we're building humanoids today, and humanoids are not like machines. You don't have a set of instructions that you program or a bunch of sensors that is getting an input, and then you have a logic, and then it gives an output. Humanoids are effectively learning organisms. So the way we train a humanoid today is through telematics. So if I'm picking a piece of paper, I pick it, and then there is a telematics that is telling the humanoid they got to do the same thing the way the human is doing. And this is how you train the humanoid for with millions and terabytes of data, so that they get to 50% of the efficiency of a human. So I think this continuous training and evolution will feed into the digital twin model as well, so that you don't have to have a bunch of people sitting in a conference room trying to simulate this digital twin. It will all be a living organism getting data continuously. And I think that's kind of where the world will move towards. So introduction of humanoids will change the game completely, because that's effectively modeling what a human would do, and that's the real digital twin that we're talking about in the future.
Gotcha. That's the cyborg. If you've never watched, like Drew and I watched the Joe Rogan podcast and listened to it, and I don't know, Elon, who's who's heavily involved in this and in all of this world, is he was talking about how we already are like just heading towards being cyborgs. You think of your smartphone attached to the human, and I think it's going to make for an interesting future. I think it's going to be something to stand back and watch. And I've learned a lot in this episode. So thank you both for spending some time with us and going through the digital twins and how you use it. And I think for the audience out there, the big thing is, if you're looking to de-risk, if your system is large enough where it makes sense, like, this is a really valid option for you to make some good operational decisions. It's not cheap. Drew said that, but it's, what's the cost of not doing it? How much time is spent, how much effort's lost, how much inefficiency is in the market, or what's not made. We talk a lot about medical devices, Sriram, and it's like sometimes it's a patient, not a package. And so missing a delivery means a whole lot more and has a whole lot more significance than just missing a metric. And it means you've missed somebody that critically needed something that was supposed to be shipped out, or maybe it's from a defense sector of you've got, some type of important piece of equipment that's down and they need a part, and the only place it's coming out is the warehouse where that part is, and you miss that shipment, and now a mission can't go forward, or something critical for, the freedom or defending the world. So I've enjoyed it. We've come to our end. I'll give it out and say, hey, does Drew or Sriram, do either one of you all have any closing comments, or just maybe say goodbye? And we've had another good episode.
Ready for the weekend. Another busy weekend ahead. It's coming.
Yeah.
No, I just want to say thanks again. I hope you guys enjoyed the conversation. Again, this is a lot to discuss, and I'm sure we probably might do another episode of how this is really coming to a reality in various parts of our ecosystem. But no, I think, like I said, I think both Zion and Addverb, we believe in cutting edge technologies to change the world, and I think kind of true to our statement as well. At the end of the day, it's about collaboration. It's about humans and robots coming together, humans and machines, humans and data, however you want to put it. And I think all of this is kind of transcending into that world where it just makes it a better place for all of us to live. I mean, if we can solve problems within the warehouse where we can make the life of the associates there easier, and they can live happier, they can go back to their home feeling much better. That's really the goal. That's what we are here for, and I'm sure, I think between Zion and Addverb, that's what we stand for. So no, thank you, and like Drew said, I hope you guys have a great weekend too.
Yeah. Well, Sriram, Drew, thank you all again. Audience, thanks for spending some time with us. And if you got more questions on digital twins, you can reach out to either one of us. We'd be glad to have more conversations with you. So thank you, and we'll see you next time.
Thank you.
We want to thank you all for listening to another episode of the Zion Experience. Please make sure you subscribe to our show on YouTube, Spotify, or Apple Podcast. If you have any ideas or topics you'd love to hear about, or maybe for a future episode, please let us know. Send us something in the comments. We appreciate you all, and we'll see you here next time.